Hi friends, this is Grishma from CSCA section second year BTech from Shankara Institute of Technology. Today my mathematical foundation of computer science topic is mathematical logics and truth tables. Introduction of a mathematical logic. Preposition. A preposition or statement is a declarative sentence which is either true or false but not both. The truth or faith or falsity of a proposition is called a truth value. The two values true and false are denoted by the symbol T and F respectively. Sometimes these are also denoted by the symbols 1 and 0 respectively. For example, consider the following sentence. First one, Delhi is the capital of the India. Calcutta is a country. 5 is a prime number. 2 plus 3 equal to 4. These are the prepositions or statements because they are either true or false. Next, consider the following sentence. How beautiful are you? Wish you happy new year. X plus y equal to z. Take one book. These are not prepositions as they are not declarative in nature. That is, they do not declare as a definition truth value T or F. Prepositional calculus is also known as a statement calculus. It is the branch of mathematics that is used to describe a logical system or structure. A logical system consists of 1. A universe of preposition. 2. Truth tables or axioms of the logical operations. 3. Definitions that explain the equivalence and implications of the prepositions. First one is connectives. The words or phrases or symbols which are used to make a preposition by two or more prepositions are called logical connectives or simply connectives. These are 5 basic connectives called negation, conjunction, disjunction and conditional and biconditional. First one is negation. The negation of the statement is generally formed by writing the word not at a proper place in the statement preposition or by prefixing the statement with the phrase. It is not the case that if P denotes a statement, then the negation of P is written as P and read as not P. If the truth value of P is T, then the truth value of P is F. Also, if the truth value of P is F, then the truth value of P is true. Table 1. Truth table for the negation. P and negation P. If P value is true and negation P is false. If P value is false, negation P value is true. For example, to consider the statement P, Calcutta is a city, then negation P is Calcutta is not a city. Although the two statements Calcutta is not a city and it is not the case that Calcutta is a city are not the identical. We have translated both them off by P. The reason is that both these statements have the same meaning. Conjunction. The conjunction of two statements are preposition P and Q is the statement P and Q which is reads as P and Q. The statements P and Q has the truth value T whenever both P and Q have the truth value T. Otherwise, it has truth value F. Truth table for the conjunction. P value, Q value and P and Q value. Here true, false, true, false and false. For example 3, consider the following statement P. It is raining today. Q. There are 10 chains in the room. Note, usually P and Q. It is raining today and there are 10 chairs in a room. Note, usually in our everyday language, the conjunction and is used between two statements which have same kind of relation. Thus, a statement it is raining today and 1 plus 1 equal to 2 sounds odd. But in logic, it is a perfectly acceptable statement formed from the statements it is raining today and 1 plus 1 equal to 2. Example 4. Translate the following statement. Jack and Jill went up the hill into symbolic form using conjunction. Solution is let P equal to Jack went up to the hill, Q equal to Jill went up to the hill. Then the given statements can be written in a symbolic form P and Q. This symbol is referred as a and. Disjunction. The disjunction of two statements P and Q is the statement PRQ, which is read as PRQ. The statement PQ has the truth value f only when both p and q have the truth value of f. Otherwise, it has truth value t. Truth table for disjunction: PRQ. True, 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 false, true, false, true, true, false, false, false. For example 5. Consider the following statement P. I shall go to the game. Q. I shall watch the game on television. Then P or Q equal to I shall go to the game or watch the game on television. Conditional preposition. If P and Q are any two statements or prepositions, then the statement P gives rise to Q, which is read as if P, then Q is called condition statements or preposition or implication, and the connective is the conditional connective. The conditional is defined by the following table: truth table for conditional. P, Q and P, this symbol is known as conditional. P gives rise to Q. True, true, true. True, false, 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 true, true, false, false, true. In this condition statement, P is called the hypothesis or premise or antecedent, and Q is called as the consequence and conclusion. To understand better, this connective can be looked as a conditional promise. If the promise is violated, the conditional is false, otherwise it is true. For this reason, the only circumstances under this which conditional P gives rise to Q is false is when P is true and Q is false. For example 6. Translate the following statement. The crop will be destroyed if there is a flood into symbolic form using the conditional connective. Solution: let's see. The crop will be destroyed. There is a flood. Let us rewritten the given statement as if there is a flood, then the crop will be destroyed. So the symbolic form of the given statement is F gives rise to C. Let example 7. Let P and Q denote the statements. You drive over 70 km per Q. It is P. Q. You get a speeding ticket. Write the following statements into the symbolic forms. You will get a speeding ticket if you drive over 70 km per hour. Second one, driving over 70 km per hour is sufficient for getting a speeding ticket. Third, if you do not drive over 70 km per hour, then you will not get a speeding ticket. Fourth, whenever you get a speeding ticket, you drive over 70 km per hour. Solution: P gives rise to Q, P gives rise to Q, P gives rise to Q, and Q gives rise to P. This is the difference between the statements. Thank you.